to him so he can present his paper entitled Graphical Analysis of Captured Network Packets for Detection of Suspicious Network Nodes. So over to you, Felix.
All right, thank you very much, Grace Fox. I'm grateful for this opportunity. Yes, my name is Felix Larbi Aryeh. I'm presenting this paper with Professor Boniface, Kayode, Alese, and Olayemi, Olasehinde. The topic is the graphical analysis of network packets for detection of suspicious network nodes. So this is going to be the mode of presentation for this paper. I'm going to briefly give a brief introduction, talk about the research experiments which we conducted, and give us a discussion on the results that we have. Then a conclusion on what we've done so far. So generally, as we already know, attacks in the cyber world continue to spread as new paradigm emerges with data, because big data keeps becomes more accessible. So the rise of these attacks and also advanced cyber attacks keep posing tremendous threats on the availability, the confidentiality, and also the integrity of data. In situations where the data is stored or during the processing phase or the transmission phase. You can also realize that virtually every successful computer networks, whenever there is a successful computer network attack, you can see that it becomes vulnerable. And in such situations, you have vital information which are being stored on those networks being available to the entire public domain for people to access. So in such situations, you have so many people, you can have some of these public information in the newspapers and stuff like that for people to see, which shouldn't in actual fact be possible for them to see. Now, this paper has two main objectives. You could realize that when dealing with network packets, it's always very difficult to get hold of each packet and also analyze each of those packets. So in situations, you see network administrators or network analysts all trying to use Wireshark to go through each of these packets, and you can see it's always very difficult filtering and also following the TCP stream. It's quite difficult. So now this paper will leverage the Python, Scale, Panda, and also Seaborn libraries to help analyze the packets that is being captured in the network. So for the capturing process, the Scapy library will be used, and also for the manipulation section, we will be using the data frame, Python data frame, and also in the creation of the visualization of the packets that we have, we will use Seaborn. We use Seaborn for that. So whilst incorporating all these, we'll be able to come out and see those suspicious nodes that are on the network at the packets level. Now moving on. Yes. So this is, sorry. So this is the case study that is being used that was being used for the research. So this is the network infrastructure of the University of Mines and Technology, and the capturing process was done at the Network Operations Center. We realized that from here there is the network, the ISP provides internet service to the institution. And this goes to the NOC, and at the NOC there are lots of servers. There are so many servers that are running on the network. We have the Active Directory running. We also have application servers, be it Big Blue Button for video live conferencing, and also we can also have a virtual learning environment server that are also available at that particular at the NOC. Now, all computers that are on the local area network of the institution are all get access to the internet through what we call the proxy server, which is a free BSD. So that serves as a firewall, and after also serving as also a proxy for all the users that are connected. Now from here, you can also realize that at the NOC, We also have base stations located at vantage points to give access to internet. And at the base stations, you have Windows server. There are Windows servers that are set up at those base stations that are running on routing to give access to people who are on the local network, and also there are wireless devices or wireless routers that are also available that is deployed online for people to have access to the internet. So in all, we have about 8 base stations that are all linked to the main network operation center. And that is how the internet access gets to users on the network. Now, the capturing process for this work was conducted on the 27th February for a period of 2 hours. And this was put on the live network. So we would be able to capture enough packets to make analysis. We also realized that a robust network sniffing tool, which was the C-MRiC, was used to give us access to sniff and also load packets. And finally, also save the packets in the PCAP file, which will be used for analysis for our analysis. Now, continuing from here, so usually whenever you're dealing with large quantity of networks or network packets, it is always very difficult, as I've already said, to go through each of these packets and make inferences of them. So hence, we try to create some sort of visualization in the form of graph that will make it quite helpful for understanding the trends and also the pattern of that particular packet. So in this case, we leverage matplotlib, the Seaborn and other libraries like the plotting to help visualize the packets that we captured at the network operations center from all the network nodes that are available on campus. It is also unnecessary to spend countless times, trying to determine whether a captured file or a traffic contain a benign or malicious attack, especially when dealing with suspicious networks. So that is why we try to leverage the data frame to help gather relevant information about the statistics of the packet network. And so from the figure, as you can see, figure 2, it gives a statistics. From figure 2, you can see we have a statistics of the packets capture on the UMass network. And from that, we have about 86,464 packets that were captured using the C-MRiC library. And out of that, as highlighted, you can see we had the transmission control protocol having about 14,278 packets being captured. And the user datagram protocol too, we have about 55,000. And the ICMP, we have packets. And any other network, 16,000 packets that were being captured. We were to the analysis. So figure 3 gives us how the conversion of into the yes, hello. Yes, so from here you can see the graph. These two graphs gives us the merit of highlighting some of the anomaly spikes in data when scouting for malicious artifacts in any kind of network. Now, we have about 4 figures, so figure 6, 7, a grouping operation carried out on our research, in our research. So the grouping was done for easy categorization of the source and the destination addresses, as well as the ports and other attributes. So from figure 6, you can see that the payload of all the traffic coming from each of the respective IP addresses shown. And from that, you can see that the source IP address 192.168.1.20 had the highest combined payload, which provided 23.5% of all the source IP addresses that is shown in this particular figure. So this majority of the request payload which is made on the network came from the node which is designated with this particular IP address. Now, figure 7 as well also gives the destination addresses together with the payload sum. So you can see from here that most of the highly grouped destination address is the 192.168.1.225, which is which gives us about 28.7% which is the destination IP address that was most prevalent amongst all the destination IP address in terms of the payload sum. From figure 8 and figure 9, it also highlights the fact that large amount of data were sent from port 80, which was 20, and also port 443, which was 21, over to port 10,001, and also port 1,900, which also yielded 11.2%. So from here, you can see that the source protocol used for the transmission of these high volumes of data were respectively HTTP for port 80 and also HTTPS for port 443. So we also know that when we're talking about port 1090, it's a UDP INR official port, which is mainly used for simple service discovery protocol, which is meant solely for the universal plug and play devices that run on the network. And again, you can also see this port, which is the 10,001, is also used for the UDP INR unofficial port for ubiquitous wireless devices or access points, routers, VS routers as well, to broadcast to ports probably 255. Now, from what we gathered over here, we can also say that exfiltrating data using ports 1001 is one of the common practices that hackers use to restrict ubiquity devices in terms of the wireless access point and also routers as well. And this is mainly because most of the users that we have are most of the time connected onto the wireless network access points or routers that are on campus. And from the figure that we see, which is figure from figure 10, you can see that most of the frequent address was speaking to this particular IP address. This is 255. So figure 10 shows the destination IP address of 255. From what we've seen, we can say that it may be a suspicious address that needs some sort of attention, since we already know that ports 255 in the network sense, it's mainly used in the internal network, and also it is used for broadcasting. So only servers, most servers, most systems, but network, it's most of the time always used for broadcasting. So whenever we see any sort of abusive activity running on that particular IP address, it is either coming from within the internal network, and sometimes the reason for having this spike in figure 10 will be that there's probably ubiquitous wireless routers or access points that are found on the system, or maybe there is an error happening. So in situations like that, it's always advisable for the network administrator. It's advisable for the network administrator to try as much as possible to go into the system, the network, and try and figure out what is causing these particular spikes. From literature, we've realized that whenever we have these 255 broadcasts spiking up in network, there is a cause for alarm, because there might be some sort of misconfiguration of those network devices, be it the access points or the wireless routers. All right, so the research that we conducted show how the broadcast IP address, which was the 255.255 on the port 1009 and 101, being some sort of suspicious within our internal network. So the suspicion was based on the payload data that was sent to this address and the possible misconfiguration on the ubiquitous unified access points or routers. So from the research again conducted, we can also see that the adoption of Python and data science techniques can help open doors for possibilities in the arena of network packet digitalization, and also with continuous practice, we can also unearth many artifacts in the network packet stream. So this will be the references for this work. And finally, thank you very much for this presentation. Yeah.
Thank you, Felix, for that. We had a little bit of trouble hearing you a couple of times, but I think it just added to the suspense of the findings, you know, so we'll take it. So to our attendees, if you have any questions, do pop them in the Q&A and we can present them on to Felix then. I might just ask you, and it's the same question I asked Armin in the previous presentation. So what's your next steps for the research?
Yeah, this research actually forms the basis for another research that we've already started, which we virtually complete. I think this was supposed to help us find out if indeed there is some sort of anomaly happening on the network. And once there is, then it means we can capture traffic and also possibly create our own kind of synthetic packets. So in this case, we were actually working on a network, an application that is able to capture packets on the network. And once we have those packets captured, we are able to use it for machine learning to figure out how we can classify classify any of the packets into the right categories. Yeah.
Brilliant.
So this forms the basis for the research.
Sounds good. I wish you the best of luck. So we've no questions coming in. Mohammed just said great. So, oh, here we go. First he said great, so that was some nice feedback. So what he said was, would you explain the Python libraries and data science techniques to ease packet capture and analysis for your process?
Yes, this is what was done. When you using the SCEPI library, SCEPI is a library that helps us to gather packets. So from that, the packets that we capture, we have it in the form of a pcap file. So we are able to import the speaker file into the data frame. And once it's within the data frame, then we can run analysis on each of the files in the data frame to be able to see the some of the information that I talked about. We're able to see the TCP stream, the UDP stream, and also the ICMP stream, all the kind of protocols that are available within the network.